All right. Season 3, Episode 6, Take 1. Welcome to Quantum Kinetics First Diffusion, Season 3, Episode 6. I'm here with
Jason MacCoy.
Jason, it's good to have you back on the show. What are we going to be talking about today?
So many interesting things. We're gonna take some viewer questions. We're gonna talk about UFOs. We're gonna talk about.
I think they're called UAPs now.
UAPs now, yeah. You could change the name, but it's still
the same thing.
Still a flying saucer.
It's still a plasmoid.
Yeah, and more, right?
Absolutely.
We're gonna talk about fusion. The saying "fusion is love."
Yes.
And it happens to be Valentine's Day, so shout out to all you Valentine's lovers out there.
Happy Valentine's Day to you, Jason,
Thank
and
you.
everybody else.
Thank you.
Hope you have a Valentine out there. So let's go ahead and head off on the first question, which is from Hayden.
Ash Hayden, yes. He asks, is the QKW producing exotic vacuum objects as coined by Ken Shoulders, and is this perhaps the source of transmutation? Now you're gonna have to break that down for the average viewer, myself included, of what is an exotic vacuum object?
Yes.
Who is Ken Shoulders? And what does that mean in terms of transmutation?
Perfect. Okay, so Ken Shoulders is kind of was an inventor. He died in 2013.
Okay.
He worked for MIT for a little while. He also worked for SRI. He is an inventor, and he's basically the father of the micro vacuum electronics. And what that means essentially is that he was really good with transistors, he was really good with vacuum tubes, he was really good with electronics in vacuum situations. So he was really good at manipulating electrons.
In a vacuum.
In a vacuum specifically, yeah. Kind of like in space.
Now what you're doing, just to jump in on it,
Here
we go, as always, right? We have a script and then we just jump off.
Do we want to talk about the exotic vacuum objects next, though?
Sure.
What is that?
Well, that's what it's gonna ask you is, what is an exotic vacuum object? It's not like a vacuum cleaner where they.
Well, it sucks a little bit, yeah, sure.
But I mean, what you're doing is that you've mentioned in the past that what you're doing has a lot to do with the electronics.
Yes.
But you've also said that it doesn't have to be in a vacuum, but it could be it works better in a vacuum.
It does work better in a vacuum, yeah.
Yeah,
and so to Ken Shoulders' exotic vacuum objects, what that is essentially is he talked about this thing about a white hole and a dark hole in his electronics and his transistors and all this stuff. Is he basically, when there's a white hole, that's an electron pushing, and when there's a dark hole, that's an electron being sucked, or a positive, right?
Okay.
So that's where this idea of exotic vacuum objects, what he was really interested in is these clusters. They're called basically electron clusters, where they would form toroidal donuts, essentially, of electron density. And they didn't know why it was doing that. It would just show up in his electronics and his inventions and all that. And they were trying to harness that technology. And what they did was, one of the things was they talked about rotation, certain rotations going one way and then another rotation going the other way. So there's counter rotational action causing like Victor Schauberger's swirling actions, right? And so it's interesting that, there's Ken Shoulders is kind of mysterious because he was a really genius inventor, but really there's not a lot of discussion about him or even information on him. He has well over 15 patents, but they're all obscure. But they are about controlling the electron, right?
Yeah.
And what a vacuum object is, in my opinion, is essentially it's the opposite or conjugate of an electron. So an electron has force carrier charges that push out, like this spheroid. But what a vacuum object is essentially is when you dephase the electron, it creates this toroidal basically singularity, right? Oh yeah, it creates a singularity like this, a toroidal singularity. And that when you meet the criteria for this event in physics and electronics and transistors and stuff, you can get that to happen. And then when you turn your circuits off, the universe goes back to normacy, and then it goes forward in time, And when you're in this phase change with a toroidal, exotic vacuum object, you're basically going back in time.
So
which is antimatter. It's going back in time. It's still an electron, but it's going back in time in a singularity. And then you turn off your circuits, and then, boop, you're back into a different time frame. Which we could talk about the UAPs and UFOs and all that. They kind of do the same thing.
Sure. Well, we brought in some toys.
Yeah.
Just
before we talk about toys, I just have to make a really quick shout out to Ethan and his toys. He sent us this as a thank you, and he wants us to basically mention him in the podcast. So thank you, Ethan, for the toys. It's an Iron Man and what do they call it? War machine. So he just wanted me to shout out to that. So thank you, Ethan.
That's so cool.
Much.
And just a message to all the viewers of we invite the two-way conversation.
Absolutely.
We love getting the messages. McKane can handle the science stuff, and it's so great to see what people are interested in, what they're asking about.
Yeah.
And UFOs is something that has been in the news because there's so many people coming forward and saying they're whistleblowers and talking about their experiences. What once was kind of a fringe thing has become
normal.
Like we're all expecting it now, so this is a toy that I had from when I was a little kid, and I've noticed as you have on yours there, they all have this shape, right? This saucer shape, where the term flying saucer came from. Why do you think it's that shape, and what could that possibly be doing for the functionality of a UFO?
Yeah, so to go back to Ken's shoulders with the exotic vacuum objects, essentially, is that when you're trying to do a space-time charge or space charge polarization effect on the universe, you're trying to create more of a black hole type of situation, a dark hole. Because when you make a dark hole, electrons want to fall in and fill it, because nature hates a vacuum. She hates it. She will always fill it. And so what basically UAPs and plasmoids do is that they create a very special situation like Victor Schauberger, where they swirl the electrons into a situation where they lose their update function between the positron and the electron. And that in a normal mode situation in the universe where time is on point, it's 1 click, 2 click, 3. It's like gears going click, 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 click in a gear. But when you create these exotic vacuum objects with these transistors and special electronics, you can create the gear slippage. The gears will slip in the universe. The time frame gets kind of distorted, and it gets missed. And then the quantum world starts becoming strange, where it's not just like, I've got a bag of M&Ms, but the bag of M&Ms will go through the table if I drop it, right? Like weird stuff starts happening.
Yeah, they say that the way the quantum world works is different than the world of matter. Like once you get small enough, the rules change, and other things are possible. Yeah,
essentially is nuclear fusion can happen. Nuclear transmutation can happen at room temperature. You can turn lead into gold at room temperature. These things start happening on a higher probability, right? Because in a normal situation where matter and antimatter, they're all stable. They're stabilized, right? But when you create the situation with your electronics where you destabilize the time frame between matter and antimatter, then you can have slippage. You can have magic happen. You can have, more energy out than you put in. You can have all these amazing things that nuclear fusion is supposed to do at room temperature that's safe nuclear. And that here at Quantum Kinetics, using the ARC reactor fusion on demand technology, we are the first to fusion registered trademark as of February 10th.
That's awesome.
So congratulations, investors, and all you people that have helped out with Quantum Kinetics. We are dominating right now. It's amazing. Our research verified, like you like to say.
I like to remind you to say it. Yeah.
I know.
Yeah. No, that's great. And I mean, I think that's something, we were talking about this in preparation for the show. When people think about, when any investor thinks about what it means to invest, myself included, because I am an investor.
Yes, you are.
And I said this the very first time, was that one of the things that I found compelling about a claim, because I'm an inventor too, I have a patent.
Yes, you are.
And
numbered notes.
Yeah, when you make a claim, it really forces you to be like, is this legit? Is what I'm claiming legit? And you have One of the things I like to remind you of that's so special about this effort and this project and this business is first to fusion sustained how long?
So we are officially sustaining nuclear fusion in this room right now, and it's been going on for 12 months as officially.
Wow. Now that's shocking because all the other claims are like 22 minutes and
A couple seconds.
and that's awesome in a sense, right? Because they have a tokamak reactor or a stellarator or laser ignition,
Inertial confinement,
or they shoot the penny thing at the vacuum ball thing.
Yeah, so inertial confinement is where they take the spheroid ball, and it's like a tritium ball, and then they shoot lasers at it, 196, 998 lasers, and it bounces off the wall, and the X-rays are focused into the pellet, which then cause ignition at the National Ignition Center.
Right.
And so they use X-rays to do fusion. The lasers are not shooting X-ray lasers because, by the way, making an X-ray laser gun is literally like the hardest thing to do in physics. To make an X-ray laser diode is like impossible because of the size of it. It's like 0.1 nanometer size. So when we have a device that actually emits X-rays as a beam of energy, like a gamma ray emitter, a gamma ray burst, dude, that's an amazing technology. The arc reactor is the pinnacle of nuclear fusion and diode science right now. And we're doing low-grade nuclear fusion right now in this room, and we're having a podcast. It's no big deal, right? Because it's safe.
Yeah.
Now, we can turn it up and it will do a little bit less safe, but we're not doing that anymore, only when we do research with industry partners that are global isotope experts.
Right.
We do that. So our technology has been research verified. We work with industry partners that are specialists in science. We get our data from, the best labs in the country in terms of like analysis of ICPs and all that stuff. So for the average viewer again, when you say it's research verified, when an investor goes, this looks cool, but I don't know if I'm ready to make that jump. I don't know if this is like everything they're saying. What does research verified mean? It means that we did a strategic partnership with the Department of Energy back in 2019, 20, and 21. And then we went through all the proper protocol that they set forward for the experiment.
Yeah.
They were the professionals saying, we're going to do this. We're going to do chamber blanks. We're going to do, source sample water testing. We're going to do treated water sample testing. They set the criteria and we followed it. Then we took the numbers that we got from the experiments and then did an analysis together. Okay.
So research verified means that the people that are qualified to validate what was done, in fact, did validate it. And that means you're ready to take the next step to go beyond basically friends and family and seed investing to angel investing, right?
To any kind of investing, right?
Yeah.
I mean, literally, this is, again, like I say in the other podcast, that nuclear fusion has never gotten this, cold nuclear fusion has never gotten this far in history. This is it, guys.
Right.
Like every video podcast we do, you are looking at the leading edge of a neuron going into a new, creational idea of the universe, a potential.
That's so exciting. It's so fun.
And it's even crazier too, is that like when we submitted our research from the DOE to Nature NPJ Clean Water, we heard back within 3 weeks after they reviewed it. 3 people reviewed it, and they said their reviews were, you're accepted, but not only are you accepted as peer reviewed and we're going to publish it, the reviewers actually had great comments. And I can't disclose their names because we're all under NDA, but they said basically in a nutshell is, 1, this is amazing technology and it should be implemented everywhere in the world, was one of the comments. The second comment was essentially the same thing, except for we've never seen anything like this before.
Wow.
And these are the peer reviewers.
And what does peer review mean? Because I remembered on the one of Terrence Howard interviews, he was saying one of the challenges of getting new technology into the marketplace is that you have to get it peer reviewed. And he's like, well, you're not a peer, so we're not going to review you.
Was Weiselman or Weinstein?
I can't remember who it was.
Joe Rogan?
It was one of those interviews where he was basically, Terrence Howard was lamenting that like, hey, I'm offering it up for people to review it.
They wouldn't.
They wouldn't review it. But how did you manage to get peer reviewed and get into scientific magazine?
Yeah. So we went to the Department of Energy and said, hey, we're going to do an experiment on electrolysis. And that's what we thought it was too at first. We're like, well, we'll see if we can do fusion, but it looks like electrolysis. So when we got the data back, they were like, man, we don't really want to write their manuscript. You write the first draft. And I'm like, well, I'm not a scientist. I'm an artist. Why would you have me do it? I'm paying you all this money. So they just had me write the first draft, and I wrote it, and I took all their data and said, with all this information I see as an artist who is learning the terms for 3.5 months, 4 months, I wrote on the heading of it was electrophysical transmutation. And when I sent that draft to the Department of Energy, they said, yeah, that's what we thought too. And I was like, okay, well, and so we finished the manuscript together as a group, and then we submitted it to Nature for clean water. And they were like, man, this is great. These X-rays, the exotic X-rays are wonderful. The numbers are showing transmutation with ICP values from source to chamber blank to treated. It's all good. And so the only thing that, and when I wrote the patent on it, I didn't realize that I wrote the patent just like Ken Shoulders talked about the exotic vacuum objects. I had no idea about Ken Shoulders till very recently. But when I went and looked at Ken Shoulders' work and how he wrote his stuff, and I was looking at my patent, I was like, dude, I wrote that like Ken Shoulders, but I didn't even know him. I didn't even have any idea.
There's parallel, these things kind of cross and intermingle, and the connections between different things is remarkable. When
music, waves,
harmonic
oscillators, resonant chambers of cathedrals, maybe even like the atom itself,
cymatic patterns.
I mean, if you're not paying attention to the world around you about how everything's linked, you're gonna miss out on so much stuff.
Yeah, it's remarkable. One of the things, and one of the inventors that we are going to talk about is Helene Hadsell, who created this thing called the SPEC method.
What's it? I don't know what that is. What
it's
is
basically, okay, so this gets a little bit off the like hardcore science stuff into, well, I consider it off into like visualizing something that you want and obtaining it. And so her method, the SPEC method, I'm kind of looking it up here, is to see it, to project it, and then to expect it, and then to collect it. And that method was her method. She won all these different sweepstakes, and had an incredible track record of winning different things. And she was adamant about this idea that you sort of forged an outcome by calling it into existence through the universe and then having it actually happen.
That reminds me a lot, Jason, of being an athlete and like a Division I athlete at the University of Washington.
Oh, yeah.
And one of the things that, sports psychologists would tell us that would come in and kind of like do speeches to the, all the Division I athletes on the track team was that, if you want to break a record or you want to jump a certain height or you want to run a certain speed, you have to visualize it, you have to train for it, you have to bring it into your mind and repeat it over and over and over so many times that it actually becomes real, right? Like you're conditioning your mind to make it into reality through your body. Yeah. And that's part of training too. Like if you are an athlete in anything you do, and even an artist too. Like I have a vision that I see way back here that no one can, I haven't actualized it yet, but I'm going to keep scratching at the paper to make the drawing and make it kind of massage it out or sculpt it out with a sculpting agent. Like your brain is able to pull information from a higher collective consciousness, I believe, very much like AI. Because the way AI works is like AI is a software essentially engine that basically pulls from a database of like all this information that you want it to pull from. And then you tell it what you want, and then it compiles all this information iteratively over and over and over until it makes the picture you want. Very much like our own brains work in the world.
Yeah.
And my question to you, Jason, if that's the way our brains work, And that's how AI works. Can we make any universe we want with our own intention?
Boy, that's such a... This one I really think hard about, because the practical side of me wants to say it's all physics and it's all probabilities. And we just imagine stuff around that. Like, that's one side of it. But on the other hand, I've had personal experiences where I have thought about something happening and it has happened. I have, I was telling you about when I was a little kid, we used to climb on trees, and I think it was called flying squirrel or something.
Where's your mom? Like, don't jump out of the tree.
This is early 80s kind of stuff. So everybody was working and kids were like, you just outside doing whatever, and whatever was climbing trees. And we were literally jumped from tree to tree. But there was a, I'm not recommending this, by the way, but there was a point where you knew if you were going to try to jump to another branch, you had to be all in. You had to, there was nothing else to focus on than the fact that that branch was the branch you were going to catch, how you were going to catch it, what the trajectory was. If something went wrong, the next branch down, and you were 100% focused. But it helped so much because you just got locked into hitting that target, making that thing happen.
And so when you made the jump to the branch, you had to make a decision that literally because there's a little thing in your stomach that goes off, that goes, I'm going to do it now.
Yeah.
And there's a part of you that says, no, I'm not going to do it. I'm not going to do it. I'm not ready yet.
Yeah.
And then that moment where you click from like, okay, I'm doing it.
Yeah.
Would you say that you in your mind are so laser focused on making it a reality?
Oh, yeah.
That you can't undo it?
Yeah. It was basically like 1, 2, 3, jump. Once you started counting down 1, 2, 3, or counting up 1, 2, 3, jump. Once you went into it, it was all about what happens when you jump.
1, 2, 3, jump.
Huh. Wow.
Make the jump, right? And 3 is a very important number. But when I was a pole vaulter, I remember this when I was running down the runway.
Oh, yeah.
It was at a state track meet.
Yeah.
And this is very interesting. It was a really important jump. If I didn't make the crossbar, I would have been out of the state competition. And I was favored to be the winner by a huge margin going in. And there was this, as I was running down the runway, it was so important that everything started to go in slow motion. Like every step, every movement of my arms and the pole, it was like slow motion. And then I planted the pole started bending, it was swinging up. And as I got inverted and I was going up, anti-gravity being pushed up by the pole from potential to kinetic energy to kinetic energy to potential energy.
Right.
As I was going over the crossbar, I remember the universe seemed to stop. And I was able to do a million calculations like move this, before like the universe could even catch up to what I was thinking. And I cleared the bar, but I remembered that moment like, whoa, I just slowed down time. It felt like I just slowed down time. How did that happen? And I know you were telling me a story about someone that had a similar situation.
Absolutely. So when I was teaching at the UW, we had one of the classes was a storytelling class. So it was all about like, everybody has personal stories, but not many people really know how to tell the personal story, because to tell a good story, you have to set up what the story is about. You have to define the details. You have to establish what the stakes are of the story, why we would care, or why it's funny, or why it's moving sentimentally, or whatever. That's where it all happens. And the way the class ran is I told everybody in the room, hey, everybody has something about their lives that's kind of interesting and kind of unique.
Sure.
Turn that into whatever you turn that into something, and that's going to be your project. That's
an animation.
An animation,
right.
yeah.
3D animation.
A 3D animation, yeah. And I think I was telling
you. On the computer.
Yeah, if you're a project planner, you'll probably recognize that wasn't a great idea because everybody's doing different stuff. But it was for the advanced class, and this one guy happened to be a Marine, and he was saying that he was coming back from a mission in a Humvee, and it hit a...
was he in Afghanistan?
I think so. It was a deployment, and he hit a IEP, or an improvised device,
landmine.
A landmine kind of thing.
Oh man!
It he was saying that time stopped for him. He remembered being in the Humvee as it was spinning and flying in the air. And he goes, all I remember is this bag of gummy bears that they had was just suspended up in the air as he was like spinning around. And
like a spiral.
Yeah. And he goes, it seemed like a minute where I was just looking at he goes, I could see every individual gummy bear. He goes, and I remember looking at each one of them in detail, but it happened in like a fraction of a second.
Okay, so how in physics, now let's back up from the metaphysics to how in the physical world could that make sense?
Well, I think there are a couple ways. Like,
shoot.
Okay, here we go.
Hit it.
Hit
it, boss.
Okay, there's a couple ideas here. One is perhaps our brain is tracking the world around us at a particular frame rate. This is like a biological version. Mm-hmm. So maybe when we're super stressed out, that clock rate kicks in way higher. Like we go from like 30 to like 60, frames a second. Yeah. And we can remember, because we're so laser focused, it's a crisis, it's something extreme happening, we kick into like ultra focused mode. And we can remember stuff.
Yeah.
On the other hand, I do find it so interesting that like around planets and black holes, time dilation stretches time.
And slows it down.
Around more like heavier masses, right?
Yeah.
So there's I don't know, it's some kind of combination.
Can I ask you a question about that?
Yeah.
Is in a time dilation event, like a UAP or your brain slowing down the frame rate, how do you make in animation on a computer, how do you make it seem like it's going slower motion?
You sort of stretch out how slow things happen over more frame rates.
On my iPhone, if I do 60 frames a second and I play it back, it looks normal speed. But if I go over to slow-mo mode and click on it, how many frames per second is it?
Probably 100 or probably 30 or something.
It's 120 frames per second.
120.
So there's more frames in that unit of time.
Yeah.
So then it makes it look like it's going slow motion.
Huh.
So what's happening in my theory is that gravity, your brain, and all that, it's able to pump in more frames, more photon radiation. It's able to pull in more of the exotic vacuum object, negative light, basically. Excuse me. Which is funny because people are starting to comment and copy what I'm saying for the last podcast. But anyways, what happens is if you can get more frames in, the universe begins to slow down. Or at least it looks like it's slowing down-ish.
Right. Huh.
So if you can get more data in, which is more photons, and by the way, this actually totally makes sense because in general relativity, E equals mc squared. But that's not quite right. That's only half the equation. E equals plus or minus mass times the square of light. But it's even more complicated than that. It's E is plus or minus energy equals plus or minus mass equals the square of light. So there's a one-way light, which nobody knows how fast one-way light is. It could be instant. But there's a two-way light, which is basically, 300 and whatever meters per second or whatever, or 300,000 meters per second. That's the two-way light. Nobody knows what the one-way light is, and that's I say that is instant anti-light. And that's why gravity can be felt everywhere in the universe equally, is because antimatter and gravity and anti-light all operate on that dimensional plane of instantaneousness. And we can use our brains to pump in more instantaneousness and go places or slow things down.
Huh, cool.
But if you have to focus it. It has to be focused.
Yeah.
Your brain, like you said, well, you're focused. Everything gets better. But it costs a lot of a CPU. It's a huge amount. I did kind of
say it that way, did I?
You totally said focus.
Yeah.
And that's what this is you focus the CPU energy, which is also very interesting because it is CPU energy, into a point where then literally the universe stops like goes into pause mode with no resistance. And if there's no resistance in the universe in that very spot, you can be anywhere you want instantaneously and then turn off that, and then boop, you're in a different time frame. Not
Wow.
You're in the same space, you're just in a different time.
Wow.
Space is kind of like it's kind of a goofy term. There's no such thing as space and time. It's space and time. They're different.
All in one kind of concept.
Yeah.
Thus, they're warpable.
It's warpable.
It's warpable, and because it's warpable, that opens up all kinds of ways to behave within it. Right? You can. Is that what? So, quantum entanglement is a idea that has two objects directly connected, no matter what the space is.
And quantum entanglement only works if you change one thing to one thing. If you say you're up, I'm down.
Right.
If I say I'm up, you're down. It's like it's a two-way light thing. It's an entangled thing, but the blanket of infinitesimal quickness is all about that negative space, which is basically 4D or 5D or however you want to do it, like plasma intelligence. There it is.
I know, that's I've told you this before too. Like,
there it is.
I struggle so much with the stuff that gets metaphysical, but on the other hand, we just don't know what is beyond what we know. It'd be like if a caveman, like if you told a caveman that it's possible to talk to somebody on the other side of the planet, they would tell you, like, I'm talking about a caveman that's got language. I'm not talking about the guy making fire and whacking stuff with a bone,
Do you know that they found out that the first caveman made fire like 20,000 years before they thought? Just recently in a cave.
I bet they were, hey, necessity is the motherhood of invention, right?
Yeah.
I mean, imagine you're in a cold cave and the fur coat isn't doing the job and you're like, I bet they saw lightning hit a field and something lit on fire. They took that thing on fire, they added more stuff to it, and they're like, we can keep this thing going.
Yeah.
And by the way, how do we get it started?
Is it a nuclear fusion light that we're talking about? Can we keep this going? Can we make it bigger? Someone caught lightning.
It is crazy to think about this concept all the way back to like cavemen with fire in a cave, all the way to nuclear cold fusion, right? But
I've made fire, nuclear fire, right?
Yeah. And with a lot less energy in a totally different way. That's one of the other things that we were going to talk about. The things that there's so many different things going on in fusion right now. Fusion news, right?
Oh man, yeah.
And so I think this is a great conversation because the audience is looking at all these different things coming through the news feed, and they're interesting.
Yep.
And they all say something along the lines of, so and so is about to get fusion working. So and so has could
maybe
get working
potentially.
Yes. And they got it working for a little bit of time, and they had to turn off, and they had to spend $1 billion, and then they put $1 billion more in. They had a warehouse, and they're spending all this money.
Hundreds of millions of dollars later.
Yeah, hundreds of millions of dollars later, and they're getting it working, so that's cool in a way, right?
You got to give them props for firing and hitting 150 million degrees. Helene just did it 2 days ago, and they made a big press release. Actually, I think it was yesterday. And their press release said something along the lines of like first fusion or industry first fusion, which is interesting because that's a little bit close to what we're saying like for the last 3 months. But congratulations, Helene, for doing that. Good work. I know that you guys are using like 1 million volts and like 100 million amps or something like that to make that happen at like less than a millisecond. But like that's at like what, 1 hertz per 1 hertz. That's 1 seconds fire. Seconds fire. Like they're using deuterium tritium fuel for that 150 million degrees, and they were using deuterium to get 100 million degrees. But the thing is, we can hit those temperatures with the exotic vacuum, objects essentially with the arc reactor at 1.9 watts. We can do nuclear fusion with the air using the exotic Ken Shoulders vacuum objects with special electronics.
With way less energy, way less infrastructure.
It's here, man.
And way more consistent results, right?
Oh, bro, it turns on 100% of the time.
And it doesn't create hazardous waste. Because I think a lot of people think anything that has to do with fusion or nuclear energy is going to create hazardous waste. Does the Quantum Kinetic Well and what you're doing create any nuclear waste?
The only thing that it actually makes that we've seen in our science is that it makes chromium-51 from the experiments, because we use stainless steel, and then because of the neutron flux that's going back and forth, it causes the chromium that's in the stainless to become a little bit unstable and beta decay. It's ringing, basically. But after the thing about chromium-51 is that the beta decay life is, 29 days? So if you just take the sediment and all that stuff and put it in a container and let it sit there for a month, it's no longer got anything wrong with it, because everything's going towards iron, everything's going towards nitrogen and all these inert things, right? So when we put uranium in the water, it fractures the uranium, it spalates it down into thorium, tungsten, and lead, and all these other elements. So the answer to your question is, yeah, it makes chromium-51, which is basically beta decay active, but only for 29 days.
It's such a small half-life, is that right?
Yeah,
it's
a super low half-life, and the radiation emission spectrum is super low.
And then when you mentioned in the past that you can take, basically, speaking of like the way regular nuclear energy works, it creates hazardous waste, right? And this is a huge problem in Hanford and Fukushima. One of the things that I remembered you talking about, like with investor money, that you might or intending to do is to create a water treatment fusion system that can basically process toxic and hazardous water. What is that all about?
Yeah, so using the ARC reactor, the exotic vacuum objects, stimulation via, microprocessing technology and integrated circuit chips, that we are able to do something that no one's ever been able to do at a commercial scale. And it's low gallonage flow rates to an intermodal container that has, the quantum kinetic fuser all in a rack. There's 12 of them, and they're just pumping water through them, in and out, and back into a tank, collection tank. And the minerals and the deposits and the fusion process of carbon, nitrogen, oxygen fusion, coagulating these particles together, basically electron knots, are just falling into the tank, and we collect them, and we use them for industry. And if you pour radioactive waste through it and pump it through, it decons the radioactive wastewater, which would be coolant water from nuclear fission plants. It could be wastewater that's from some other process, like at Japan and Fukushima. I mean, we can do the impossible with these micro electronic systems.
That's amazing. I bet a lot of people are saying, great, let's make one. Go ahead and press go on that. Whoops, sorry about that, Iron Man. Happy Valentine's Day.
He was giving a high. Yeah, you want to get on the accent.
Happy Valentine's Day, bro.
That's awesome.
No, but I think a lot of people out there are thinking, okay, great, make one of these things, right? Let's do it. Let's get at it and let's start processing water. But one of the kind of cool things about what a potential next level of investment would do is to be able to make these. So if you had again, with a bit of funding, what is the water treatment thing that you would make? What is that?
Yeah, it depends on the size, right? I mean, if you do a 10 by 8 intermodal, you do a 20 by 8 intermodal, you do a 40 by 8 intermodal container.
And wait a minute, what does intermodal mean?
Oh, I'm sorry. Intermodal container is like, those trucks that have the big containers that are rectangle that we store.
Like the shipping containers, like boats?
Yeah, it's just one of those, except it could be a small one or a big one. And you put and here's the thing that everyone needs to understand about going from benchtop proven technology to commercialization. Here is the thing.
Preach on.
Here it is. Like, if you have a benchtop model that works, the feasibility and the economic time variability of that to be useful for industry is zero, because it doesn't make enough sediment. It doesn't go through enough water to be economically viable, and it would just take millions and millions of years if you just had a couple of reactors on the bench. But if you have a bigger unit that can process more water in a certain shorter amount of time, this is when you start getting the dial turned to profitability at a quick pace. And so the fact that we've proven it on the bench, and we've proven it to last and work for 12 months now without any, except for just flushing. And, it's ready. The economics is ready. All we have to do is go build it, like in the Field of Dreams, go build the baseball field in your backyard and they will come.
Yeah. But first you got to prove that it works, and you've done that.
Oh,
right?
yeah. We spent $2.5 million, basically. So
Wow.
far. Which is very interesting because when we talked to the COO of Google Cold Nuclear Fusion back in 2020, he was like, if you're going to do a cold nuclear fusion experiment and do it at industry level to get it proven for sure, without a doubt, it's going to cost you, McKane, $3 million. That's what he told me. Over dinner. He flew out to talk to me. Okay. This is how much you need to get it proven. And we've spent 2.5, which is in the ballpark.
Under budget.
Under budget. Everything that we can do with cool nuclear fusion can be under budget from whatever the hot fusion guys are doing right now.
Yeah.
No, we could have this operational by 2027 late.
And operational means that you can start processing toxic water, hazardous water, remediating water, the term, right?
We could start leasing the first milestone project. That's probably what we would do too, is just we'd build the unit, and get a couple people to sign up for a leasing agreement for a couple months. And then we just do it like that. And then just get on the list, and then we'll make more of them.
And the thing you mentioned that most investors come to, and I was too, like, that's why I relate with this so much. Like, I relate with this because I don't have like a bunch of money, but I thought, and I feel this makes sense, and it's such a valid thing, was the first thing I asked you. So it's research verified. How? That it's proven that it works. I think that's such a compelling foundation to build on, because that's the foundation that establishes everything else that comes after that, in terms of investing and in terms of proving that it works. And you're already having it work on a regular basis, so we're past that milestone. Yeah.
Mm-hmm. Yeah, we're way past that milestone. And actually the hot fusion guys are basically saying that they're doing first industry fusion of 150 million degrees like Helene. And it's like, we did that back in 2024 in November, bro. You're a little late. Like, and you guys getting more money all the time. I mean, like Avalanche Energy just got another $29 million like 2 weeks ago. And they're doing, benchtop nuclear fusion with high voltage and low amperage. And, everyone's trying to do it, and they've got all this money. And so this is the question I have. We're putting ourselves out there. We're doing our maintenance of our patents. We've done the research. We're showing you that it works. We're teaching you about Ken Shoulders. We're teaching you about all these people that have done this in the past that didn't get credited for it, And this is like my question to you, the audience, is, don't you think that's kind of weird? Why is there all this millions and millions and millions of dollars not going towards helping us? You got to start asking the question, like, does history flow like water or a river, and does history repeat? Are we going through the same situation that Nikola Tesla felt back in 1900s? I say yes, because there's an establishment that says no. This is it changes too much. But if we don't change, we've said this before, we're running out of time. We got to start making action happen. And if it's not going to happen from large institutions, then it's got to be grassroots. Terrence Howard said, a little bit ago, it was on a podcast. He said that essentially he's running into the same problem. He has way more money than we do, and he's running into the same problem. He can't get his stuff published. The academic community won't publish his stuff.
Right.
We got through, and now they won't even let us do any more publishing. Like, I've tried many times. We did a deuterium oxide experiment with the same reactor that at one point Nature was like, yeah, this is amazing. We did the same experiment except with deuterium oxide, same parameters, same government, DOE. We did the same thing, just with different dielectric medium. We submitted that to them, and they said, go away, never talk to us again. So what's going on here? That we have to start asking questions like, dude, is something up here?
Well, I think what's up is that it's an amazing opportunity to get behind the technology that could change all of that, that is revolutionary, that does do something unique and novel and is effective and is proven. I just think that's so exciting. You know, I mean, as every inventor, right?
Yeah.
Every inventor, it's like you have the thrill of it, as we talked about this in the past, is touching the universe, like shows you this magical light that is innovation. And you see the potential of it and you're like, whoa, I'm going to devote my life to bringing this into the world, because the world would be transformed by this.
Yeah, right.
You know, I know I'm preaching to the choir again, but
well, you feel it too, right? Like, I know you like, I don't know how much I can share, but I mean,
Sure.
I know that you're working on something really amazing too.
Yeah.
Which I understand that you can't talk about, but every inventor has a magic bullet, you know, golden gun from James Bond, right?
Yeah.
They all have the golden bullet that they're got in their waist belt, that they'll shoot other bullets, but there's another one down in there.
Yeah.
And I know you've got one, and I've got a couple that I don't even, I mean, we're talking about transmutation of radioactive nuclides and like time dilation stuff with nuclear fusion. I know you got something big there too that actually is complementary to this technology.
Yeah.
And the thing that the message I have for me on this side for today's podcast is this: as we get, you know, we're getting to 15 minutes before an hour, is that nobody is going to come save you. The billionaire class is not coming to save you, as we all know now. And this is historical reckoning, as Melinda Gates said. Nobody is coming to save you. We all have to come together as a people, as a group that has good intentions for our neighbors, our daughters, our brothers, and everyone else. And you get to make the call of free will to change the future, because this is it. It has never gotten this far before. So if it's going to happen, you have to be the one to make it happen.
And how do people get involved? I guess, you know, like commenting on the show, writing in, potentially investing, potentially sharing the podcast with somebody, even that, you know, like just...
Yeah, small things. Like you said, just share, like, comment, and, you know... Subscribe. There you go. I mean,
maybe we should say that at the beginning of the podcast.
Yeah, well. And if you have money to spare, like, it's very interesting. Like, we have investors now. We have, like, a whole bunch of them. And they're keeping it going, which is great. Thank you so much. And we couldn't do it without your help because, you know, we've already spent so much just to get it verified. You know, it's not like... And you were telling me a story about like today about how you had a client that had like this really nice car, and then it's like,
oh yeah, dude.
Okay, you're spending money on some car that's like $200,000, where you could just get away with spending money on a $68,000 car that's really nice. You got to start thinking further ahead, man. That's all I got to tell you is like people that have money and people that have abilities to change the world, you know, and have disposable income, you got to start thinking about the future. Because if we continue on this dark path of the status quo, it's going to be bad.
Yeah.
And this is hope. Someone emailed me from Canada about a month and a half ago. And he said, McKane, I love seeing that there's a new video podcast. And I'll tell you why. Because it gives me hope.
Yep.
Your podcast represents hope. And that means so much to us because it is hard to do these things. It costs money to do these things. It's expensive. Everything takes our time, you know. And thank you, Jason, for donating your time to do this.
Happy to. By the way, it's an honor to do this. I enjoy this. It's a lot of fun. It's like physics therapy where we get to talk about
this is like PTSD for humanity. This is it. And happy Valentine's Day to y'all, because like this comes from a place of love. You know, I discovered something magical, but it was really a gift to me. I asked for the gift, it was given to me, and now I'm trying to share it with you guys. And we can make amazing things happen to the world and ourselves even. And I can't do it alone. And that's it. Like we all need help. And I'm trying to help you understand. I'm trying to help you understand what's possible and give credit to people in the past, like Ken Shoulders, Stan Meyer,
Victor Schauberger.
Victor Schauberger. Bro, Victor Schauberger was the man. The more I learn about that guy, the more I'm like, dude, hands down, props.
Yeah.
Tesla level stuff, right?
Yeah.
And like, I just want to say thank you to all the investors and all the inventors and everyone else.
Yeah.
This is it, guys. It's an honor, but man, oh man.
Well, there's so many great inventions out there that could move the needle so far. You know, we know that, and that's something that I think the spirit of every inventor, you realize that these problems are so addressable. They're so fixable. Mm-hmm. We just have to, one of my notes here is the boat coming into the harbor metaphor, and we'll wrap up here. And I know we were gonna.
I'm so glad that you brought that up.
There is always a better way to do something that takes less energy, less force, smarter, faster, easier, nicer. But we start off with the brute force method. Even like when you're coding, lots of times a beginner developer will code something out in the most like rigid way without using things like loops and lists and other things. It's a primitive way to get the job done.
It's basically just like it's a sketch.
Yeah.
It's a sketch outline of like what I needed to do.
And then it goes even beyond that, is that when a beginning developer will just take every task and list them out one by one. Sure. They will not take advantage of a smarter way to do it.
Right.
Because they don't know.
Just get it on the plate.
Yeah. But when you start to learn more about what's possible, you start using the tools in a more efficient, effective way. And that obviously is where the solution lies.
Yeah.
So this thing about the boat coming into the harbor, tell me more about that. When we were talking about that, you were explaining how that's kind of a metaphor for the way the or the hot fusion industry is working.
Mm-hmm. So the analogy is like if you have a boat and there are rules to being a marine boater, right? Yeah. One of the major rules that I learned as a kid was when you come into a harbor and you're speeding, you're in the open ocean and you're speeding towards a harbor, you have to slow down.
Right.
And you have to get rid of your wake. And so the boat has basically little to no wake. But as you come into the harbor, you don't want to cause a wake so that all the other boats that are in dock, they don't start moving a lot and crashing into the docks and damaging them, right? Hurting them.
Right.
And so the analogy that we were talking about on the phone was that when you do hot fusion, you're coming into the harbor and you're not slowing down and you're going zipping in and going to your slip. And now there's all this wake and turbulence in the harbor, and everyone's like, dude, what the heck? Fast neutrons? What the heck? Radioactive waste, borated concrete walls? Man, what's going on here? You're doing your docking and you're coming in and landing. That's fine. But bro, don't you realize that for every action, there's an equal and opposite reaction here in the universe? And so if I'm coming into your harbor, if I am a flying saucer and I fly into the planet, okay, I don't just fly into right next to your planet with all that inertia and stop. No, I come into your solar system first, and then I slowly come towards your planet to respect the gravitational flux, to respect the flow, right, the wake. Because if I come in too fast, I'm going to disturb your moon, and then now you've got problems, right? So when in space travel, what you do is when you make a jump, you jump from one galaxy to another galaxy. You first use the fast mode, and then you come into the outer side of the galaxy, and then you slow down. And then you use this thing called, it's basically radar. It's a security band. It's 1.42 gigahertz, which basically makes you move fast through time, but no wake. So you have to understand that for every action that you do, if you're going to do hot fusion, you're doing some nasty stuff to the universe. And it's possible, and this is a theory, just so you know, that if I'm doing something to this piece of metal right here, and I'm shooting it and zapping it, doing fast hot fusion. Is it possible that also right here there's another electron that is being disturbed too by whatever you're doing here? This one's feeling it too. What if these are two galaxies, two universes, that if I do something here, this one feels it too, like a reverb? This was one of the reasons why we probably stopped doing so much nuclear bomb testing, is because when you do bomb testing, nuclear bombs, you make an echo around the entire universe.
Right. I mean, it just, there is no thing that happens in total isolation. It all kind of reverberates through our planet, through our immediate solar system and beyond, right?
You gotta be gentle with love, because if I'm doing physics out of love, I'm not gonna hurt the universe or my neighbor, because this is about Valentine's Day. This is about love. This is about getting to the point of
take it home.
I want, take it home. We got 5 minutes. We can do it. When you go to the store today and get flowers and chocolates for your girl, you're doing it because you want her to feel special. You're doing it because you want to make her have a smile, and you want her to have that warm feeling inside her heart that she's important. And every time we do nuclear fusion, we should totally think that way. Because here's the thing, when you do something nice for your Valentine's today, you're going to get something back in return, right? What are you going to get? You're also going to get a big hug and a big kiss on the cheek and all those things, right?
The editor is running triple, double overtime right now in my mind.
I know, you're like, PG-13.
Don't say that. Yeah. But yeah.
Yeah, so like, fusion is love, and love is fusion. You don't have to force it. It just happens.
Well said.
So, yeah. Anything else you want to say on Valentine's Day, buddy?
That's perfect.
It's been a really fun episode. I actually kind of want to go further, but I think we should probably end it here. But
sure.
Thank you so much, Jason. I have love for you because it takes a lot of bravery to come on the show and speak at the global level, especially about something so pariah as cold nuclear fusion. So I thank you, and Brighton and Randall and everyone else, that has come on.
Yeah.
Even Dana, thank you so much for coming on and being, and doing what you guys do.
Everybody contributes kind of in their own way and their own thing. I thank you for saying that. It's an honor to be part of this project. And, but I just feel like it's a fun chance to talk about science, learn more about what you've done and kind of the way you think about stuff, talk about these topics of the day, learn about science, teach the world about these concepts. It's a pleasure.
Well, we really enjoy having you on, Jason.
Thanks.
And I'm looking forward to talking a little bit more about the one big electron with you.
Absolutely. Oh, yes, we mentioned that. To all the viewers out there and to everybody watching, please send in your thoughts on that, and we'll use that as a starting point for that conversation about that, the one big electron, because we tried to dive into that. I got lost. We'd love to see what other people think about it and then take it from there.
Yeah. Well, we have a lecture coming out pretty soon with Brilliant about the one big electron.
Perfect.
So that'll be launching probably next week late. So
cool.
But we'll dump the next. I think we should do the next episode is going to definitely be about the one big electron, and we look forward to chatting with everyone about that. And remember, it's okay to be wrong. It's okay to think outside the box. Richard Feynman said too that quantum thermodynamics is so wild and crazy. It's okay to be wrong, and if we don't accept the fact that maybe we're wrong, and we don't have a little bit of fun with it, we're not going to grow. So let's not be rigidified and put ourselves in a box. Let's go have some fun.
Sounds good to me.
All right, guys. Thanks for coming on the show, or thank you, Jason, for coming on the show.
Sure.
And thank you, everyone, for tuning in. And we will see you on the next one. Take care.
Bye.